Today I am going to discuss about RC firing circuits of SCR. Last class we have discussed resistance firing circuit. There we have seen that there are some limitations of resistance firing circuit. Resistance firing circuit was not suitable for firing more than 90 degree of input voltage. Here we will see that this limitation is removed by RC firing circuits. So let's start. In resistance firing circuit also we have seen that there are two basic conditions required to turn on the SCR. Anode must be connected to positive and cathode to the negative supply. Second is minimum gate to cathode voltage is required to turn on the SCR. In resistance firing circuit, we have developed that minimum gate to cathode voltage across the resistance R. Here, that voltage is developed across capacitors. Now let's see the circuit. In this circuit, input voltage load SCR, variable resistance R, D1, D2, capacitance, these are connected. R is a variable resistance. Now the purpose of this D1 and D2 is to allow current in the forward bias condition and block in the reverse bias condition. Now here I am assuming that you know the fundamental of R, RC, RLC circuits with AC excitation. From the fundamentals we know that capacitor voltage lags the supply voltage by certain angle depending upon the value of the resistance and capacitance. We can see input voltage, load, resistance, capacitance. A simple RC circuit is there with AC excitation. So the voltage across the capacitance will lag the supply voltage or input voltage by certain angle based on the value of R and C. That means that lagging angle we can control by controlling the value of R and C. Here C is fixed, R is variable. So by controlling the value of this resistance R, we can control the lagging angle. In positive half cycle, current will flow through load R, capacitance and back to input voltage. With capacitance upper plate positive polarity and lower plate negative polarity. In negative half cycle, just the reverse. That means across the capacitance, lower plate positive and upper plate negative. But here is one difference, that current will choose a minimum impedance path. In negative half cycle, current has two options. It can go through R or pass through D1, but D1 will give lesser impedance path. So it can be assumed that all the current passes through D1. In negative half cycle, the direction of current will be through input voltage, capacitance, D1, load and back to input voltage. Advantage of this RC firing circuit is that we can trigger our SCR more than 90 degree. Generally it is 4 to 176 degree. This 4 degrees minimum firing angle and 176 degrees maximum firing angle based on the turn on time of the SCR. Because at 0 voltage we can trigger our SCR. So some magnitude of input voltage is required across anode and cathode. And disadvantage of this circuit along with the R circuit also is slow turn on process. So let's see this one. In the positive half cycle of input voltage, capacitor charges through R. In the negative half cycle, capacitor charges through D1. The purpose of D2 is to discharge the capacitor and to block the reverse voltage appearing across gate to cathode junction of SCR. So this will also provide reverse voltage protection across SCR. So D2 has two functions. First, to discharge the capacitor to the gate of SCR, and second, to protect it from reverse voltage. Now, in the positive half cycle, anode is connected to positive supply, cathode to negative supply. At the same time, you know that capacitor voltage is lagging the supply voltage. Lagging means when input voltage reaches maximum value, then still capacitor is at a voltage which is less than its maximum value. Let's see the simulated waveform. Top one is the input voltage, second is your capacitor voltage. From here clearly we can see that capacitor voltage is lagging the supply voltage. At t equal to 0, The horizontal axis is time axis. At t equal to 0, input voltage is 0, but capacitor voltage is negative. It indicates that capacitor voltage is lagging. Now, this capacitor voltage is slowly increasing. Input voltage is reached at its maximum value, but still capacitor voltage is building up. Now, as soon as capacitor voltage achieves minimum gate to cathode voltage required to turn on the SCR, then the capacitor will discharge through D2 and thyristor will be on. In resistance firing circuit also we have seen that across the resistance, if minimum gate to cathode voltage is developed, then thyristor will be on. Here also, if capacitor is able to develop minimum gate to cathode voltage, our SCR will be on. When the SCR is on, the capacitor is now completely discharged and the voltage across the SCR is reduced, and close to zero it is reduced. You can see the flat path here just after achieving threshold gate to cathode voltage. After that, again capacitor will charge in the negative half cycle and it will lag the supply voltage by certain angle, and when capacitor voltage again reaches minimum threshold value, then the thyristor will be on. This cycle will repeat. So two important points you can conclude from here, that capacitor voltage is lagging the supply voltage, and second point is as soon as capacitor voltage reaches minimum gate to cathode voltage required to turn on the SCR, thyristor will be on. Now let's see here. Once the capacitor voltage reaches threshold value, after that the voltage across the capacitor reaches close to 0, and during that duration our thyristor is on and the voltage across the thyristor is 0. And in the negative half cycle, again thyristor will block that voltage and voltage will develop across the SCR. Already we have discussed that when the SCR is on, voltage across the SCR is 1 to 2 volt, and when the SCR is off, this voltage will be there but current will not flow through the SCR. Suppose you want to control the firing angle of this triggering circuit. If resistance R is reduced, then positive half cycle, more amount of current will flow through charge the capacitor. So quickly the capacitor will charge. So the time constant is reduced, or charging time constant is reduced. So R is known as firing angle controller. So by changing the value of R, you can control the firing angle, and this firing angle can be achieved close to 180 degree. If R is large, then capacitor will take more time to charge. Time constant of the capacitor RC, it will increase. If time constant increases, then the capacitor charges slowly. So the capacitor will achieve minimum gate to cathode voltage at later angle or after more delay time. Generally, the time constant of the circuit is greater than or equal to 1.65 times the time period, and time period is 1 by frequency. Now, Vc is equal to minimum gate to cathode voltage, I am saying, but actually it is minimum gate to cathode voltage plus voltage drop across the diode. If it is a silicon diode, then 0.7 volt drop we have to consider, and if it is a germanium diode, then 0.3 volt. So likewise 0.3 to 0.7 volt drop we can consider, and VGT is the triggering voltage or minimum gate to cathode voltage required to turn the SCR on. At the same time, input voltage must be sufficient to develop this Vc plus RIGT. Otherwise, thyristor will not be on. That capacitor voltage plus voltage across the resistance R, because of the minimum gate current IGT. IGT is the minimum gate current required to turn on the. So these two conditions should be satisfied to turn on the SCR. Capacitor must be able to develop a voltage equal to diode voltage drop plus minimum gate to cathode voltage. and source voltage must be more than or equal to capacitor voltage plus R into IGT. So today we have discussed about RC firing circuit. Here we have seen that by controlling the value of resistance R, we can control the time constant, or you can say charging time constant of the thyristor. We don't have any control about the discharging time constant. If favorable condition is there to discharge the capacitor through gate, then thyristor will be on. In next class we will see UJT firing circuit. So RC firing circuits, in our firing circuit we have seen up to 90° we can control, but not more than that was possible. In RC firing circuit we can control more than 90°, but it is now a slow process. So we will discuss UJT firing circuit that is faster than this R and RC firing circuits. Some more merits of UJT firing circuit we will discuss in next class. Thank you.